Hello and welcome to our channel, Tech Expert Tutorials. In this video, we will teach you the basics on how to use the Pandas Concat, merge, and join functions. These functions are widely used in data analysis, data science, AI, and data engineering projects. Here is a summary of the comparison between these three functions. Deciding which one to use depends on your situation. For example, Concat can join horizontally or vertically, and join can merge three or more data frames. First, we need to set up our Python environment with these Conda commands. If you are unfamiliar with Conda, see our video on Python, Conda, and VS Code, link in the description below. Here is the full list of setup instructions. Now we import the Pandas and NumPy packages or modules. The as command allows us to abbreviate later. In this case, we set up PD for Pandas and NP for NumPy. We will start with examples for the Concat function. Concat can work along the X or Y, meaning row or column axis. This is how merging horizontally on the column axis or axis equals 1 looks, similar to an inner, outer, left, or right join. And this is what merging vertically on the row axis or axis equals 0 looks like. It is similar to a union join in SQL. We create 4 simple data frames for examples, each with 4 rows and 4 columns. We also use some duplicate indices in df4 to show how key duplication will affect the concat function. Our first example shows how we can create a list of data frames from df1, df2, and df3 without using Pandas. However, Pandas gives us more options and functionality in how the join output will look. Here is our first example using Pandas. It is a simple concat statement, which vertically appends our first 3 data frames into a new data frame with 4 columns and 12 rows. Here are the 3 input data frames in the order they were added. Now, we will join 2 data frames horizontally by using an axis value equal to 1. We use an outer join here to keep all data from both frames. Outer joins may create a lot of NaN value cells, which can cause issues with other functions. The usual fix is to convert the NaN values either to blank for text or 0 for numbers. We can also choose to ignore the index, which will prevent duplicate column values in the output. If we switch to an inner join, we can only keep the rows with matching index values. In this case, they are 2 and 3. If we choose to re-index the result, this will effectively create a left join using the exact index from the original data frame. We can add a series as a new column by using axis equals 1, or a new row by using axis equals 0, which is the default, and then transposing the series. Transpose converts a row to a column and vice versa. Next, we will cover the merge function. We create 2 data frames, one named left and the other named right. We can merge on the key value from each data frame. Now we show how to merge on multiple column keys. We create 2 data frames, each with 2 columns of key values. Then we do a left join on the 2 key columns. The result shows both key columns along with the non-key columns from both data frames. There are 2 rows that are non-matching, so we see NaN values again. Now we will show you how to merge when we want to check for unique keys using the validate parameter. The first example shows a failure due to the duplicates in the B column. Notice the error. It mentions keys are not unique. The B column contains duplicate values of 2. We change the B column to a unique list and no longer see the error. Column names are also duplicated. The A sub X and A sub Y columns indicate the column name A and the data frame either X and Y, meaning first or second input data frame. Finally, we cover the join function. We create 2 new data frames, left and right, each with 2 columns and 3 rows. Then we join left to right using a left join. The right data frame does not contain a K1 key, so we get NaN values in the result. If we choose inner, we only see the keys that are in common between the 2 data frames. Here is another join example. One contains a key column, the other contains an index. This is what they look like. We are joining on the key value, which uses the key column in the left data frame and the index column in the right data frame. Since it doesn't contain a key, the index is used instead. In this case, the keys in left, K0 and K1, are duplicated. This video covered the basics for combining data frames using 3 different methods. There is a lot more you can do with these functions. We will be creating another video covering these more advanced examples, so please check back later. That's all we have for today. Thank you for watching our video. See you next time.